Example 4. Let A equal the vector -1, 1, 6, and B equal the vector 1, 2, 3, 1, 2, 3. Again, these are three vectors. They're points in 3 space. Okay, the vector A minus B is equal to, I'm going to write all of this out explicitly so you see it, 1, 6 minus the vector 1, 2, 3. Well, that equals -1 minus 1 minus 2, 1 minus 2, which is -1, 6 minus 3, which is 3. That gives us the point -2, -1, 3. The vector -2, -1, 3. That's the vector A minus B. Okay, now since that is the vector A minus B, based on the definition that we just wrote, let's dot this with itself. A minus B dot A minus B dot product with itself, that's equal to, again, I'm going to write this out explicitly, -2 minus 1, 3 dot -2 minus 1, 3. That's equal to -2 times -2 is 4, -1 times -1 is 1, 3 times 3 is 9, square root, 4, 9, 10, 14. So we end up with radical 14. Therefore, the norm of A minus B is equal to radical 14. In other words, the distance between the vector A and the vector B is radical 14. The distance between the point that A represents and B and the point B that B represents is a distance of 14. Now, believe it or not, the formula that I just gave you is a generalization of the distance formula in any number of dimensions expressed in terms of vectors. Again, trust the definition. Hopefully the geometric interpretation that we gave you helps a little bit, and it's fine to go ahead and use that geometric intuition at this point. Think about it, look at it. If you want, break it up into components, write everything out until you're comfortable with this notion. But again, it's just a straight application of basic algebra. The norm is this, and the distance between 2 points is the norm. It is a norm because that's what a norm is. It is a distance. You have that definition. Okay, so we've introduced scalar product, we've introduced norm. We'll go ahead and stop here for today, and next time we'll continue on with more vectors. Thank you for joining us here at Educator.com. We'll see you next time. Bye-bye.